by considering the equation of tangent line, our tangent line is telling us the information of any event at an instant. For this we need to see one simple example or generalized formation of a function, that f of x equal to xn. So what should be the derivative of this function, or we can say that tangent line to this function can be done with the help of simple ab initio method or the power rule, like this. Though this thing of calculation or determining the derivative can be done with the help of calculator or certain computer program, okay, it's not a big deal. But important thing, how we can get this and why we need to get this, or what the theme behind it. So let's consider this for proving. Let's see, we should know that this can be done with the help of slope of tangent line. So for the slope of tangent line for any function f can be written like along x-axis in this way. This is the slope of normal line, and later on we will apply limit delta x approaches to 0. At this point we will apply delta x, we will apply limit that delta x approaches to 0, then this function will become slope of tangent line. Right now in average form it is the slope of normal line. So now according to the given statement, f of x equal to xn, so we need to substitute the value of function. So here we will have delta, okay, it's a function as it is. So we can say at this point, substitute the value here, xn, and in this situation value of function is somehow, it is given f of x equivalent to xn. So in this formation this will become x plus delta x whole power n minus, it is can be written as it is xn, and in the denominator we will have delta x. So in the basic formulae of slope of normal line, you can say we substituted the value of a function, and that is already in the form of power in the generalized notion of n, and this n, if we have n, can be any number 1, 2, 3, 4, or any value, n may be 1000, 100, whatsoever. Situation n is kind of an index, that if you are bothering or you are counting some stars in a sky at night, so we can say 1, 2, 3, n, okay, too many, sometimes infinite, sometimes finite, so n can be any number. But here we need to determine the derivative of this function. So we substituted the value of f of function of x, so all are in this formulation. So considering this formula to the next page, we can write here okay, on this step we can apply binomial theorem. Let's expand this by applying binomial theorem, that x plus delta x n. So what the binomial theorem do? Binomial theorem is a formation to write any value in terms of its factor. Okay, so we can write this x plus delta x first factor. So similarly x plus delta x second. So plus 3 dot usually represent in the computing system or computing machine or software programming is this okay formation is going not plus sign, it's a product. So 3 dot represent the continuity of values as it is. Okay, 2x plus delta x. So until n factor. The concept is similar like this. Okay, for expanding of this power n, for example, we have 2 of power 2, it means 2 into 2. If we have 2 power 3, mean 2 into 2 into 2. There are 3 factor of 2. Similarly, if we have n factor of 2, we can write 2n equal to 2, 2, 2 or similar like this factor to the 2. So n factor of 2. So n factors of 2, this is binomial theorem is used for expanding this the nth order number. Okay, let me make this okay, let me here multiply this term to this and this term to this other with x, so it will become how many x are there in this x n total, like in here 2n, like 2 factors of 2, so there are n factor of x. So the first element of this it will giving the xn. Next in a similar way we will have plus n, and then we can say that x, this first factor, okay, at next step it will become decreased and we can say n minus 1, and of course delta x is a multiple of this one. So this delta x, okay, first this x multiply with x and then with delta x. So first xn, so it will go like n xn minus 1 delta x plus again higher order here delta x, then we can say higher order of delta x. So basically higher order of delta x means that terms with higher order of delta x. Okay, so all these terms which are higher order of delta x are considered as a junk value. So on our left hand side you can say delta x and our delta x. So at this point now we can this is this one basically this one is all the representation of x plus delta x, and as we consider here we expanded this in this formation, we expanded this with the help of binomial theorem. Okay, we applied binomial theorem on it. Now we substitute the value of x plus delta x of power n in at this place, then we should write everything as it is. So here we will have delta xn, our delta x, this value of that is expanded with the help of binomial theorem is this one, x n plus n x n minus 1 delta x plus junk value, junk values. What else here? Then we have minus xn. Next pair is minus xn, and in the denominator we will have delta x. So minus xn, and in the denominator we will have delta x. I hope it is clear until here. Okay, now I am going to cancellation part. This xn is with positive sign, no sign positive, so will be cancelled out with this one. So we will have n x n minus 1 delta x, our delta x, plus all the junk values, delta x. I split this one, okay, this one I split this one. First one is a cancel, and we split the above portion to the 2. Now we have this as it is. Now we need to apply limit, okay, delta x approaches to 0 on our left hand side as well on our to the right hand side. So what will happen? Let me generate more slides. So we will apply limit delta x approaches to 0 on left hand side, that is delta x, and our delta x. Similarly on our right hand side, limit delta x approaches to 0. And see here in this, okay, equation, delta x can be cancelled with delta x. So here there is no delta x. So there is no question to apply, to not apply the delta x. So we can say in this formation, because in the remaining part we do not have any value of the delta x. So we should write it as it is, n x n minus 1 plus, now in this part, next part, we have delta x and the higher order of the delta x scale whatsoever. So we will apply limit delta x approaches to 0 to all the junk values divided by whatsoever delta x junk values divided by delta x. So this term, this whole term will become what? This term can be written as it is, because no involvement of delta x change, and this term definitely will become 0. So our left hand side, it will become, the big average change will become an change at an instant at q approaches to p, or okay, so information at an instant, and in our result it is very much clear. We will have this output. The information of xn, okay, at particular moment, at an instant, though it is following the same ab initio method, are very simple. But the theme of this is what? With the help of derivative, we want to notice the information at an instant. We want to target some of our required thing or some big thing. We need to, okay, ignore the negligible things. For example, in case of aircraft detection in air with the help of radar, the derivatives are applying to determine the enemy aircraft at an instant. Once enemy aircraft is entering into our space, then of course our competent team with the help of a derivative can locate it, and it is not amicable or sensible that even some birds, so flock of birds are there, or someone are flying kites, and they say, oh, enemy aircraft is wandering in our space. No, there is some certain situation. So let me explain it here with the help of figure. See, this is our target is to locate the enemy aircraft, not the tiny bird. This is the target, okay? So you can say this is xn minus 1. You can say that is the among too many, okay, in space, dust particles, you can say birds, there are too many things, but our target to locate, okay, some object, required object, target object at an instant among n particles. Okay, so let me explain it. See, there are too many birds, but our target is what? To locate the aircraft. Not, okay, only this. That is what we say, that tangent, the concept of tangent line, to touch the curve at one point. This is the one point, okay, one point agenda. You can say that one point in the information at an instant. This is the beautiful concept. But so in our early classes, our teacher told us that just, okay, ignore these junk values or these negligible values. Sometimes these negligible values are also of the same importance in reverse engineering. So it's actually not exactly zero, almost approaches to zero. Like approaches to zero, that almost very teeny tiny things, okay, in comparison to the big aircraft or metallic things. So teeny tiny things, okay, teeny tiny things, very, very simple, also negligible. But sometimes if we want, our target is to okay, locate these teeny tiny things, then we will, okay, see out the other higher order terms of the delta x scale like this. Then we will we can ignore the first term, n x n minus 1. Okay, we can ignore the first term. This term can be ignored in the reverse engineering case. So especially on days of Eid al-Adha, you can say slaughtering days, Air Force is asking us to do not throw the garbage on the streets in order to avoid the birds attraction. But there are, okay, certain artificial, with the help of artificial intelligence, shooting guns which are only designed to kill the birds. But how to kill the birds? First, these machine guns are trained according to the machine learning concept with the help of artificial intelligence. They are trained to locate the birds, negligible things. Their target is not to locate the aircraft. Their target is to locate the birds. Okay, so this the reverse concept of the derivative is also useful, as well as the simple ab initio method. Hope you will get it. Thank you.